All right, let's get into section 4.6, which we talk about multiplying and dividing monomials. So that's our learning target for today. It's going to expand on some of the things we looked at in section 4.4 and 4.5. Remember, a monomial is a single term, right? So if I look here, 3x squared y to the 7, that is a single term, right? This would be a yes, that is a monomial. However, here, 3x squared plus y squared, that plus separates it into two terms, right? So that's a big no. That is not a monomial. Can be multiplication, cannot be addition or subtraction. So monomial, not monomial. So let's look at how to simplify them. And we're going to kind of relate it to what we've done already. So we started with a problem like this where I had 2 times 2 times 2 times 2 times 2 times 2. And we said, well, I could write that as a power, right? And I have a base of 2 and an exponent of 6, right? Because it's 2 multiplied by itself 6 times. So if I take that same problem, right, and break it up a little bit different, right, this would be 2 to the 4th, and this would be 2 squared. So I still would result in 2 to the 6th. So we're going to try to look at, well, what's the relationship between exponents? What do I do with these exponents? I see if the base is the same, right? It stays as 2, and then I change that exponent to a 6, right? And we're going to see that it's really just adding those exponents together. So we got to be careful though. So in a problem like this, right, I can rearrange that and say, okay, that's 2 times 3, right? Because multiplication you can reorder. And then a to the 4th would be a times a times a times a, right? A to the 5th, 3, 4, 5, right, would be that. So then I could say, all right, 2 times 3 is 6. My base is a, and there's 9 of them, right? But the shortcut would be to take the 4 and the 5 and just add them together. Because I can tell you, if you had this problem, x to the 71st times x to the 30th, that'd be a long, right, row of 71 and then followed by 30. So it's easier, right, to know that if the base is the same, I can take those exponents and add them together, right? So that would really be x to the 101 power. Now, where we have to be careful is in a problem like this, where I have numbers in the problem and exponents, all right? Because what I see a lot is we get used to this where we're adding the exponents together, and I'll say, okay, 3 times 6, that's 9, okay? Nope, that is not the case, right? So that's why it's going to be helpful to reorder it, right? Put your numbers up front, right? 3 times 6. And then I have this, which is really x to the first. Don't forget about the 1 exponent that's not written. And then we have times x to the 4th. So I have to multiply the numbers together, which gives me 18. And then here I have the same base. If I add the exponents, 1 and 4, I get x to the 5th. So make sure that you're multiplying numbers, but the property is you add the exponents. So we'll look at that. And that's all this is saying. So it's saying if you have the same base, you can combine their exponents through addition, right? So if I have x squared times x to the 5th, right? My bases are the same. I can add the exponents, right? So that would really be x to the 7th. Now, if I have x squared times y to the 3rd, different bases do not allow me to do anything with that, right? That would just be x squared y to the 3rd, right? Two different bases, you have to write them out, okay? And then here, another important thing is the bases stay the same. And with variables, that's easy to remember, but sometimes we'll see like 3 squared times 3 to the 5th. And I'll see that written sometimes as 9 to the 7th, or sometimes even 6 to the 7th, where you add the bases and the exponents. Wrong, wrong, right? Remember, base stays the same, and we would add the exponents together. So this translates to 3 to the 7th. So a couple examples here. All right. I want you to pause the video and see if you can answer these multiplication examples. See you back to check your work in a minute. All right, let's check your work here, right? Same base of -8. So I keep that base here. Adding the exponents 5 and 3, we get -8 to the 8th power. Here, base was h. So I left that the same. 4 plus 13, exponent of 17. Number 3 and 4, let's get used to reorganizing these so we have our numbers up front so we remember to multiply, right? If you put 12, you just added those numbers, right? But it's really 4 times 8, which is 32. Remember, when they have the same base, we add the exponents. Okay, so we add the exponents, not the coefficients. We multiply the coefficients, add the exponents together when the bases are the same. In number 4, we had, right, 8 times 9, 72, c squared. Really, this is c to the first. So even though it's not written, don't forget to count it and get c to the third. Okay, when we divide, all right, we're going to learn that we can subtract exponents, right? And we really did this already. We looked at simplifying these, right? Where if this were x to the 9th, I could say there's 1, 2, 3, 4, 5, 6, 7, 8, 9 over x to the third, right? Which is x times x times x. So I could cancel, right? That's 1, that's 1, that's 1. I'm left with 6 on top. So really that would just be x to the 6th. The shortcut would be to say, okay, this is x as my common base, and I take 9 minus 3. And I know that it's going to end up on the numerator side because the 9 is bigger, right? So that's going to be x to the 6. And you could put over 1. You don't need to, right? So here, I could write out 3 a's and cancel, right? Or I could just say, okay, it's a to the 3 minus 2, right? Which is really equal to a. Or, right, you're not wrong if you write it as a to the first, but you don't have to, okay? Now, this next one here, we would have b, and we'd take 2 minus 2, and we get b to the 0 power, or, right, that's just equal to 1, okay? Anything to the 0 power is just 1. So, and if you think about it, in fractions, when you learned about fractions, anything over itself is 1, right? So b squared over b squared would just be 1. Can do it with multiple variables, right? So here I have c squared, and this, remember, c to the first. So it'd be 2 minus 1. That'd be c, or c to the first. You can write it. You don't have to. Most answer keys won't have that first power there. Now, this one's a little bit tricky, and it doesn't come up as much in today's lesson as it will tomorrow. But if I did 3 minus 5, I'd get -2. Okay, so I'd get d to the -2. But I can just look at this and say, well, there's 5 d's on the bottom and 3 on top. That means there's going to be 2 left over down here, right? 5 minus 3 is 2. But the 2 left over, since 5 is bigger, are going to go on the bottom, or in the denominator. All right, so here's some examples for you to try. I want you to try these examples. So pause the video here and then come back and check your work. All right, so here in number 1, we had 7 to the 9th over 7 to the 6th. So, right, exponents are 9 and 6. Subtract them, you get 7 to the 3rd. Here in number 2, we had z to the 10th over z to the 8th. Subtract, you get z squared. And then here in number 3, 15 to the 3 minus 2, right, is 15 to the first, or just 15. Okay, remember, when it's an exponent of 1, you don't have to write it. Now let's look at some examples that combine um, some multiplication and division. Let's look at some simplifying of numbers and not exponents. So let's start with number one. All right, so if I look here, um, in the order in which you do this, it doesn't matter. But I'm going to start. I like to simplify the top and bottom first. So really, I have nine. Right, if I were to expand that out, nine A's on top, right, 8 to the 9th, and down here there's 2 and 3. So I add those together. That would be A to the 5th. Now I can still keep going because my problem has the same base and the numerator and the denominator. So the simplifying would be to subtract the exponents. So my base stays as A, 9 minus 5 is 4. So that would end up being A to the 4th, right? And if you think about it, you'd write 9 A's out and then 5 on the bottom, cross them out, you'd end up with 4 left over on top. Now, number two, we have 3/12, okay? And we looked at simplifying rational numbers with greatest common factor, right? And that's what we have to do here. These are not exponents. So don't say, okay, 3 minus 12 is 9 or -9, or however you look at that, right? These are not the same base. So I know that 3 is the common denominator of both of them. So I can reduce, right? And 3 goes into 3 one time, 3 goes into 12, 4, right? So really I have this 4 here and a 1 on the top. Now I have the same base with A, right? And 2 minus, right? Remember that's a 1. 2 minus 1 is 1. And I can write that there if I want to. And then B to the 4th and B to the 3rd. So 4 minus 3 is 1, right? And notice 2 is bigger than 1, so my answer is on top. 4 is bigger than 3, my answer is on top. Now, how the answer key would have that written is AB/4, right? This is totally fine. But remember, coefficient of 1 doesn't have to be written. Exponents of 1 does not have to be written. So number three, let's try that out, right? 14/2, right, is really like 14 divided by 2, right, which is just 7. Here, same base of x, so they're on different levels here, numerator, denominator, so I'm going to subtract 5 minus 3. That would be x squared. 2 minus 2 is 0, so I don't really have to write that, right? I mean, I could write 7x squared y/0, right? But it's really saying you don't have any y's. It's just it's equal to 1. And when you multiply by 1, it doesn't change anything. So you don't have to write that there. Your answer key would only have 7x squared. All right, speaking of answer keys, your practice problems for today start on page 178. You're going to do 13 to 31, and then a couple review ones there, 39, 52, 54, and 58. All right, you can do that on a separate sheet of paper. There is an answer key linked to the agenda for you to use to check your work. If you have any questions, you can join my Zoom or my Google Meet or shoot me an email. We'll talk to you soon.